This section is on the laws of exponents, and there's three basic exponent rules. The first one here is a to the m times b to the n equals a to the m plus n. When the bases are the same, both parts are a, you add the exponents. Here's another one. When you have two different bases inside a parenthesis carried to an exponent, you carry that exponent to each separate item. So this becomes a to the m, b to the m. This rule, the third rule, is when you have a base to an exponent and that whole quantity to another exponent, the rule is to multiply the two exponents. And now we're going to do some examples of that. In this rule here, I have 2 to the 5th. So it really means 2 times 2 times 2. Do you know how many times? 5 times. Right. And then when you figure that out, you get 32. Now, using a very similar setup for that same type of problem, I have the base the same with two different exponents, just like a to the m, a to the n. I have 2 to the second and 2 to the third. That equals 2 to the m plus n, or 2 plus 3, which is 2 to the 5th. And what is 2 to the 5th? 5 2's, multiply them out, you get 32. Now, you could bypass this rule if you wanted, and you could say this means 2 2's, and this means 3 2's, and you do get 2 to the 5th. But in algebra, we use these rules so much that it's nice to be able to use the rule for adding the exponents, and you'll be able to get an answer much quicker. And again, this answer is 32. All right, here's some examples of the second rule. In this rule, a and b are two different numbers or two different bases. So that exponent has to be put on each one separately. So here's an example. 2 times 3 to the second is 2 to the second times 3 to the second. And what is 2 to the second times 3 to the second? Let's write it out here. It's 2 2's, and then it's 2 3's. And then when you figure that out, 2 times 2 is 4, times 3 is 12, times 3 again is 36. Now, this you could also write out and get 36. Now, I got a couple other examples here. Let's set those off here. 2 to the 6th, what does that mean? It means 6 2's. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, right? Okay. When you have a base to an exponent and then that whole quantity raised to another exponent, it can be written by doing 2 to the 2 times 3, which is 2 to the 6th. When you're doing a multiplication like this, it's best to think about doing the coefficients first. So the coefficient here is 2. What's the coefficient on this part? I hope you know that that's really understood to be a 1. So first you do 2 times 1, and you get 2. And then you do the exponent part, which is x to the 4th times x to the 3rd. Do you know which rule that is? It's this one here. Bases are the same. What do I do to the exponents? I add. So that's 2x times x to the 4 plus 3. Add those exponents. It's 2x to the 7th. All right, let's do another one. I have to multiply these two terms. Let's do the coefficients first. What's 3 times 4? 12. And then let's do the exponents. What exponent is on this x? When there's nothing there, think of it as a 1. So then this answer is going to be x to the 1 times x to the 5th. And then using my rule of exponents, m plus n, what's 1 plus 5? 6, so this is 12, x to the 6th. All right, let's try another one. This is the second rule, 2a squared to the 3rd. It means that each one of these has to be placed to the 3rd. So it means I have 2 to the 3rd times a squared to the 3rd. Now this one is a combination of that last rule and the second rule. This one is now a power to a power. What's the rule for power to a power? What do I do with these two numbers? mn means multiply. So now I have 2 to the 3rd, which is 8, and then a to the, what's 2 times 3? A to the 6th. All right, here's another similar one. It's a combination of these two rules. So first, carry this exponent to each part. So I have a squared times b to the 4th squared. A squared is simplified, but b to the 4th squared, power to a power, multiply these two numbers, right? mn means multiply, so b to the 8th. Take this first one. First of all, do you know which rule I'm using? Does it look like the first rule, the second rule, or the third rule? I hope you said the third. Okay, so the third rule, a power to a power, you multiply those two powers. So the answer is going to be m to the r times 2. Now, can I do r times 2? Yeah, that's m to the 2r. That's an exponent. That looks a little weird, but that's the answer. All right, here's another one. This is what rule? The third rule again, power to a power. So x, and what do I do with those two exponents? 2 times 3. I multiply them. What do I get? X to the 6th. All right, this one is very tricky. All right, which rule is it? Is it the third rule? Nope. Second rule? No. It's the first rule. The two bases are the same. What do I do with the exponents? I add the exponents. So write that base and do x plus the quantity 5 minus x. That's c to the x plus 5 minus x. What's x and minus x? 0. What's 0 plus 5? 5. So that one's c to the 5th. You know, I want to do another example of one like that when the bases are the same. This time I'm going to have the bases be a number though. So 3 to the x times 3 to the 5 plus x. Okay, if the bases are the same, I add the exponents. Think about that one. So I write the base 3, and then I add x plus 5 plus x. What do I get? The base is 3, and I get 2x plus 5. You follow that? So be careful. Bases are the same. Add the exponents. Sometimes people try to multiply those two 3's. I didn't do anything like that with these c's. I noticed the bases are the same, so I added the exponents. Another caution, if you had c to the x times b to the x. Can I add the exponents there? No. So the answer is c to the x, b to the x. The bases are not the same, all right? What if I had c to the x times c to the 2x? C to the x plus 2x, c to the 3x. If the bases are the same, I can add the exponents. That's a little bit tricky. All right, here's this other problem here. Using distributive rule and adding of exponents. So 6y squared times y squared. So 6 times the coefficient 1 is 6. Then add the exponents and the y's, and I get y to the 4. Plus 6y squared times y. 6 times the 1 is 6. Y squared times y is y to the 3rd. Add the exponents. 6y squared times negative 2 is 6 times negative 2 is negative 12 y squared. There's 3 little parts multiplied together. First do the coefficients. 5 times 3 is 15 times 4 is 60. On the x's, let's add the exponents. So I have a 4, a 2. Hey, there's no exponent in this one. What do I do? Put a 1, right. Now add the exponent. So 60x to the 7th. Final answer. All right, here, let's multiply the coefficients. What are the coefficients? Minus 1 and 1. I like to put those little ones in there. Minus 1 times 1 is minus 1. R to the 2nd times r to the 4th. Add the exponents, r to the 6th. All right, this one. It's really that second rule, isn't it? Right? So each one of these gets to be raised to a power. So I can do 3 squared times x to the 4th times y squared times z to the 6th, which is 3 times 3 is 9, x to the 4th, y squared, z to the 6th. Okay, let's do this one. It's a little bit of distributive and some exponent stuff. 2xy times x squared, 2x to the 3rd. You see, just the exponent and the x change. Next one, a little bit tricky. 2 times minus 3, negative 6. That part was easy. What do I do with these exponents? How about x squared, y squared? 2xy times this. 4 plus 2 times plus 2 is plus 4. And what do I do with all the exponent stuff? X, y to the what? 3rd. I hope that's what you said. All right. Here, exponents again. First of all, order of operations, power to a power, I have to do first. So I'm going to keep the a to the x minus 4. Power to a power means multiply. So when I do 2 times x plus 2, I get a to the 2x plus 4. Be careful with your multiplying. Now, I'm back to the first rule. So the answer is going to be a to some exponent. I like to put a little think balloon here for my work. So what am I going to do? I'm going to add x minus 4 plus 2x plus 4. Use my little think balloon there to get the answer, and it becomes a to the 3x. What happens to the 4's? Minus 4 plus 4. Gone.